composite functions, the basics, okay? Composition of functions, composing functions, one function composed with another. That's composite function. So given f of x and g of x, if you have, I've heard it called fog before, f, and that's not the letter O, it's the composition symbol, f composed with g, that's how you read that, f composed with g, or f of g, means f of g of x, right? F of g of x. So instead of plugging in 2 into the function f, when you evaluate, you're actually plugging in a function g of x. So maybe an expression, all right? So the other way to write this just means this, where this is the variable that you're given. So if you were given y right here, this would be y right there, okay? That's what that means, all right? So you can either write it with or without the variable f of g or f of g of x, either way. The domain is twofold. All the x's that work for g of x, right? All the things how we would have a g of x domain, and all the g of x's that work in f, right? Because you're plugging that function into f. So all the things that are in g of x that actually work or give you a valid outcome for f of x, okay? So I'm not going to find any of those, but just let you know it's twofold there, that both conditions must be satisfied. So let's say given the following functions, let's find it and simplify it. F of x is 3x squared minus 5x plus 7 g of x. So I give you f, g, h, and p. Here on this particular problem, I only care about f and g, right? Nothing else. So yes, I gave you 4 functions, but that's just because I'm going to give you several problems over the next few pages where we're going to work these things, but I wanted to say, okay, f of g. So what this means is f of g of x. You could either write it that way or you could skip straight to the next step. F of something. And I'm going to use some colors here to hopefully help out. F of g of x. F of g of x. There's actually 2 different ways you could go about this right here. So I'm going to actually divide this up into 2 ways and show you. So you could either go this direction or you could go this direction. And what's going to happen is it's going to be 1 step different depending on which direction you do, and it's all personal preference. You could say f of, and then wait a minute, what is g of x? G of x is what? 3x minus 1. So you could write it this way, all right? Or you could say, wait a minute, hang on. We could say, okay, what is the rule for f? The rule for f is 3 times something squared minus, that's 5. Minus something plus 7. And what is that something? Well, what's right here? That goes into both these places. So g of x and g of x. All right? So you could have gone either direction here. And then look, if you went this direction over here, then the next step is going to be, okay, then the next step is going to be, all right, let's see. The rule for f is 3 times something squared minus 5 times something plus 7, right? What is that something? Well, look, we already saw 3x minus 1 goes in here and here, okay? So 3x minus 1, 3x minus 1. So this method goes back to this one, and watch what happens here. G of x is just that, right? I didn't mean to do that. This one goes in here, that g of x goes in there, right? So this one also goes back. So there's 1 step that could be different, okay? I prefer to do this way over here, okay, and not this step. But it's not wrong if you do it the other way, okay? It's just my preference. That's what I prefer to do. So you can go either way, left or right there, okay? I'm going to prefer the left one, but it doesn't matter. You get back to the same. In 2 steps, you're right back to where you would be no matter which way you went, okay? So it doesn't matter which method you choose. Now, if you have a professor, teacher, instructor that says do it one way, you better do what they say because they're your teacher. But for me, in my class, it doesn't matter. Does not matter. So here I'm going to say, okay, this is going to be, I'm going to actually come in a thought cloud is what I'm going to do. All right. So I'm going to come down here and say, okay, this is going to be what? 3x minus 1 times 3x minus 1. And I know some of you are screaming at the screen, especially who are not in my class and you're just watching this video for help, is that there's a formula. I don't teach formulas. So to me, students know how to FOIL a lot better than they know formulas. Again, formulas are great when you understand, but until you see them yourself, you don't really get them. Okay? So, and people mess formula up a lot more than they mess FOIL up. So I'm going to go to FOIL because you can always write it down twice and FOIL it. Okay? Even if you forget the formula. So then it's going to be 9x squared minus 3x minus 3x and then plus 1. And that's going to be 9x squared minus 6x plus 1. So that's what this parenthesis this all becomes what's down there, right? So if I get ready to write this, I'm going to come up here because I don't have a lot of space here. We're going to say this is 3 times whatever that was squared, which we know is what? 9x squared minus 6x plus 1. And then I'm going to go ahead and take this negative 5 and distribute it. That's going to give me minus 15x plus 5 and then bring down my plus 7. Okay? Or bring over in this case. So it equals that. So now I've got to distribute this. That's going to be 27x squared minus 18x plus 3 and then minus 15x and then I have this which is plus 12. Go ahead and put those together, right? I mean, that part's already simplified out there. Go ahead and put that, or this part's already simplified. Now combine it with that if it will, okay? And those two terms combine. So now what else do I have? Well, I have negative 18x and negative 15x. So 27x squared has nothing that changes or goes with it. So then minus 33x. And then you have plus 3 and plus 12 is plus 15. So there is your final answer. And that's simplified. Don't worry about the fact, a 3 goes into that. I don't care. I don't care. Okay? Yeah, you could take something out, maybe a factor or something, but just we're simplifying. Remove parentheses, combine like terms. So if that thing factored and you factored it correctly, I would probably give you credit. Okay? Because again, you would probably be using it factored later. All right? But again, if you have an instructor or teacher, you may want to make sure for sure. And if they go by the solid definition of simplified, then that's the answer they want for sure. All right, so let's look at this. H of g of x. So this means h of what? G of x. All right, and I told you I'm going to rewrite g of x. What is g of x? This goes in for this right here, right? So g of x is going to be 3x minus 1. So what I'm going to have is, for my next step, I'm going to have h of that. Okay? H of that. Let me just, I want to fix that. H of 3x. And what is the rule for h? The rule for h is this one, right? 5 times something plus 9. 5 times something plus 9. What is that something? That goes here, right? So 3x minus 1. So then this becomes, when we distribute, 15x minus 5 plus 9. And then we have like terms to put together. We have 15x plus 4, or combine, add or subtract, however you want to say it. Okay. 15x plus 4 there. 15x plus 4. So then we have this curious f of p of 1. F of p of 1. F of p of 1. Okay, so let's see what this is. This is going to be f of p of 1. Okay? It's literally f of p of 1. So what do you think it helps us to do first? Do f of p of x and then plug 1 in? No, that's way too much. Find the pink first, right? The pink, the fuchsia with the blue plugged in. So what I'm going to do is I'm going to find this way. I'm going to say, okay, I'm going to come out here to the side in a thought cloud. Okay, in a thought cloud. And I'm going to say p of 1 equals 2 times 1 squared plus 4 times 1 minus 11. And I know I didn't write the 1 in there because I'm going to do it in blue. Okay. So now I have what? Well, do the 1 squared. So it's 2 times 1 plus 4 times 1 is 4 minus 11. 2 times 1 is 2. And then plus 4 minus 11 is minus 7. And we do that, that's minus 5, right? So P of 1 equals negative 5. So guess what? I'm going to put a minus 5 right here. But I still have F of that value, right? I still have F of that value. Change, I don't like my F. All right. So that means I'm going to take negative 5, the value I got when I found P of 1, and plug that in or evaluate F at that value. So my rule for F now is this one, right? 3 times something squared minus 5 times something plus 7. What is my something? My something is this. That's what goes in both those places, right? Minus 5. You're evaluating the function there. So you got to do negative 5 squared, and there's no right way to do this except using parentheses on this one. You can't do this. That's wrong. 3 dot, that is disgustingly wrong, okay? So if you do that, don't do it. It's wrong, okay? Hopefully your teacher doesn't do that. I'm sure they know and they don't do that, all right? So then 3 times what? 25, because negative times negative is positive. And then here, I can go and multiply. Negative 5 times negative 5 is plus 25, and then plus 7. So I'm going to multiply 3 times 25 and get 75, right? Oops. Should have been doing this in gray. Oh, well, I'll change it here. So this is going to be 75. And then it's really easier to add it a different way, but this is going to be plus 32. Put those together, and you get what? 107. So your final answer of F of P of 1 is 107. It's 107. So I go out to the side, I find this in my thought cloud over here, and then I come back and plug it in here, right? So F of P of 1. So find P of 1 first, that's a value. Then take that value and plug it into the function F, evaluate the function F at that value, and that gives you your final answer. Okay? So G of P. G of P. This really means G of, that's too big. It looks like the letter O. G of P of X, which is G of P of X. And G, the rule for, let's see, I'm sorry. Let's do this. This is going to be G of something. What is P of X? This is the way I like to do it. I'm going to take this and plug in for P of X right here, right? So P of X is 2x squared plus 4x minus 11. And then the rule for G is 3 times something minus 1, right? So the rule for this is 3 times all this stuff minus 1. So then I just write all this stuff down again. 2x squared plus 4x minus 11. And then I do what? I have to distribute. So I get 6x squared plus 12x minus 33 minus 1. And then I have one thing left to do, combine those two terms there, right? So that's going to be 6x squared plus 12x minus 34. And again, they're all even. You could take a 2 out, but we're not really simplifying these. I mean, factoring these, we're simplifying them. Remove parentheses, combine like terms. But again, factoring is so useful that if you gave me the factored answer, I'm very likely to give you the credit there, knowing that it's not simplified, but that you did it correctly and even went further and beyond or whatnot. I did the wrong color again there. All right, so here, what is this one? This says P of H of negative 2. So this is literally P of what? H of negative 2. P of H of negative 2. So guess what I'm going to do first? I'm going to find H of negative 2. That's right. I'm going to come over here in a thought cloud, and I'm going to find H of negative 2. Okay? So H of something is going to be 5 times something plus 9, right? And that something is negative 2. So that's going to give me negative 10 plus 9 is negative 1. So this is now negative 1, and I have what? P. I have P of negative 1. And then, so, right, because I went over there and found this, and I took this number and brought it back in here, okay? So now this is normal evaluation of a function, right? Evaluating a function. What is my rule for P? That's this one, 2 times something squared plus 4 times something, right? 2 times something squared plus 4 times something minus 11. What is that something? Well, it's what I just found. It's negative 1, right? So I begin to work this. I say, okay, this is going to be negative 1 squared. It's going to be 2 times 1. And then put those together. Multiply. It's going to be negative 4 minus 11. And then we're going to multiply those and get 2. And then put those together. Right, they're already, can't do anything else with them. Might as well combine them. Minus 15. And 2 minus 15 is what? Negative 13. Negative 13. All right. G of h of 1/5 of a fraction. Are you serious, Mr. Guest? What are you doing? Look, just work it. It may work out nice and it may not. And if it doesn't, you're supposed to know how to deal with common denominators. Okay? So this is going to be what? G of h of what? Everybody's favorite, a fraction, 1/5. So you guessed it, I'm going to have a blue thought cloud, okay? And again, my thought clouds are because this is just part of the problem. If I don't put it in a thought cloud, what happens? I go over and work it off to the side, or I figure it out, and I think, oh, that's my answer. No, it's not your answer. You still got to plug that value into G here. So h of some value equals 5 times that value plus 9, right? Here's h of x. That's what we're using over here, right? So what is that value? Well, that value is 1/5. And that's nice because this is over 1, and those divide out and become 1s. So that entire first term becomes 1 plus 9, which is what? Which is 10, right? That value becomes 10. So this becomes a 10 here, and we want G of 10. And the rule for G is this one, 3 times something minus 1. So it's going to be 3 times something minus 1, and that something is 10. And so then what is, hang on. What is, it's not much better. 3 times 10. It's 30, right? Put that in 30 minus 1, and then put those together, and that gives you what? 29. 29. So 29, G of h of 1/5. It worked out nicely because this became a whole number of 1, right? That could have been a fraction, 2/5 or 8/5 or negative 6/5 or anything with fifths or any other fraction, okay? And then you would have had to get a common denominator and then plug it in and possibly get another one, okay? So capital F of x is x plus 1. Capital G of x is 4x plus 7 under the square root. And capital H of x is 1 over all of 3x plus 2. So what is f of g, capital F of capital G? This is going to be capital F of, let me write it the same way I've been writing them, of capital G of x. So this is capital F of something, and that of something is going to be capital G of x. So this is going to be capital F of, what is G of x? I'm going to go ahead and replace it here. It's the square root of 4x plus 7. And the rule for capital F is what? The rule for capital F is this, x plus 1, whatever you have plus 1. So the rule is something plus 1. What is the something? It's the square root of 4x plus 7. And you can't do anything with that. There's nothing out front to distribute, so the parentheses there is a little overkill, unnecessary. So what I'm going to do is come back and say this is the square root of 4x plus 7 plus 1. Can I put those together? You better say no. The plus 7 is under the radical. So a couple things about this just to make sure. If you do this, you're wrong, okay? If you do this, you're wrong. Why are you wrong? Notice the plus looks like it's under the radical. The 7 doesn't look like it's under it here. Is there any doubt here what's under the radical? No. There doesn't need to be any doubt in your answer right here, what's in the radical. No doubt whatsoever. If there's doubt, if you write it wrong, this teacher, professor, instructor will count it off. Okay? So make sure that you have that correct. That's a detail, but that's one of the things that math does for you. It makes you pay attention to detail better, and that helps you in every aspect of your life. Okay? No matter what you do or who you are. It helps you with everything. So h of f, this really means h, capital H of capital F. Nope. Hang on. I keep forgetting to write the composition with x. So of capital F, and then here my variables are x. So that's what we'll go here. So this is going to be capital H of capital F of x. So h of f, capital F. So then what is f of x? It is x plus 1, right? So then capital H is going to be capital H of that. And the rule for capital H is this one. It's going to be 1 over 3 times whatever's there plus 2. And what's there? X plus 1. And I'm going to fix this. All right. So I need to distribute the 3. This is going to be 1 over 3x plus 3, and then tack on my plus 2. Put those together. This is going to be 1 over 3x plus 5, and you can't do anything else with that. So that is h, capital H of capital F of x. Oh, I used that color again. Oh well. Capital G of capital H of negative 1. So this means capital G of capital H of negative 1. Okay? So what this means is, or what I need to do is an orange thought cloud, right? So it's going to be h of negative 1 equals 1 over 3 times something plus 2. And that something is negative 1. Okay? So this is going to be 1 over negative 3, right? Do that plus 2. And that's going to be 1 over negative 1. And 1 over negative 1 becomes what? Negative 1, right? So negative 1 right here, and that's really close to the other color. So let me go back and do that in orange. All right, so then here, this is going to be G of, and we're going to plug it back in. It's going to be what? Negative 1. It doesn't have to be the same number. It just happened to be that this time. So when we do that, we're going to have, where's my, the rule for G is the square root of 4 times something plus 7, right? And what is that something? Negative 1. And that's going to give us what? Negative 4 plus 7 under a square root. And put those together, that's going to give us what? The square root of 3. Is the square root of 3 a perfect square? Can I do anything with it? No, that's it. That's your final answer. So the square root of 3 is G, capital G of capital H of negative 1. Now look, I know you can't take the square root of a negative, but there x could be negative 1 because you ended up with the square root of 3, which is positive. That's okay. So I hope this helps out with composition of functions. I really hope the colors help you. Try to use different colors to help you there. So hopefully that helped.